In part 1 of this Google Sheets Histogram Bin Problem series, we learned how the bins are set up differently in the one-step histogram chart type compared with the two-step approach of making a frequency formula table and then displaying the counts from that in a column chart type. If you face the problem that the software engineers faced, you'll realize that when you create a set of steps, you have to decide whether to go to the next step when you just reach the high end of your range, or when you just barely go past the high end of your range. In the histogram chart type, each bin starts at the low end and stops just a hair short of the high end. So in this example, a 1.99 goes into the same bin as a 1.0, but a 2.0 gets bumped into the next bin that includes everything up to but not quite equal to 3. On the other hand, with the two-step frequency formula approach, each bin starts just a hair above the high end of the bin before it and goes up to and includes numbers that equal its own high end. So for 1.0, it falls into the same bin as a 0.5 or even a 0.01 right next to but not quite equal to 0. But a 1.01 jumps up into the next higher bin and is the same as a 1.99 and even a 2.0. It's not until we actually go above 2.0 that we jump up a step into the next bin. That so far is what I tried to explain in part 1 of this series. Now watch how to easily make perfect histograms. I'm not unhappy with the way the bins are labeled in the histogram chart type, because it's obvious that the x-axis labels correspond to the low end of the range on the left side and the high end of the range on the right side of the column above. But still, I prefer using the frequency table with the column chart type because I'm used to seeing the column label centered in the middle of the column. And for integers, like we have in this example, the presentation seems more obvious to me than the histogram chart type. But we can adjust the number of grid lines to control label placements beneath the columns. They don't all make sense, but notice the shift in perception here if we label the half steps and get the integers centered under the columns. If we used this labeling scheme, it would imply that the bin ranges for the counts shown by the columns centered above the labels start at 1/2 step below and end at 1/2 step above the value of the label. And the label represents the rough average of all the members contained in the bin, assuming they are more or less uniformly distributed across the bin range. The problem is that the actual bin range is shifted to the left of what I just described as the impression I would have if I didn't know better. But there's an easy way to fix this. First, make your bin lists so that it does start and stop on the half steps of 0.5 and 1.5. We get the same distribution, and now notice that our column chart is labeled just like our histogram chart. But what I was really after was to have the integers centered under the columns. How about if we separate the bin list from the x-axis labels of the column chart and just provide the chart with x-axis labels that we want. When you cut and paste the bin list, the chart automatically expands the data range to include the new location. Here's where you can see that, and I'll show you how to fix it right here. In the chart editor, click on the Chart Types tab. You'll notice that the data range now includes things from column A, which is where we moved the bin list to. And we don't want that. We want the chart to look for the x-axis labels that we gave it in column B to make the chart. So we change the A to a B. Poof. Now the chart software looks for the x-axis labels in column B. And we get what seems about as close as you can get to a perfect histogram. Now in part 3, I'll show you an example of why you might want to do this.